This lesson is going to deal a lot with the calculator. So the first thing we're going to look at is how to solve by using a calculator, and this is called the intersection method. Intersection means where two things cross. Okay, so to solve using the intersection method, you're going to look for points where two graphs cross, okay, or you could say intersect. So in order to do this, the first thing you have to notice, okay, is you have to have two equations. Okay, you're going to write two equations and you're going to graph two equations. Okay, and so in order for this to happen, we're going to have y1 equals, okay, and let's just assume that my y1 looks something like this. Okay, so here's y1, the first graph, and then you're also going to have y number 2. Y number 2. Let's just assume y2 perhaps maybe is a line. Okay, so here's y2. So y1 ended up being a cubic, y2 is a line, okay? And does y1 ever intersect with y2? And in fact they do, okay? So you write two equations and then you graph two equations. It only works with two. You can't have intersection with only one, okay? The next thing we're going to do is we're going to use the intersection command on the calculator, the intersection command. Okay, so I notice here that there are three intercepts. This is the first intersection point, okay, and so when I get that point, we're going to have x equals. All right, now there are three, and so you're going to have to help the calculator out just a little bit. Here is going to be x number 2, and then the third solution, okay, x equals is right there. And so what we do is we click on graph 1. Click. Okay, y1, click. Then you go to graph 2, you click on it, click. So you're telling the calculator, y1, the green graph, y2, the red graph. Then you click on, okay, or very near the intersection point. If I click in this general area, the calculator will zero in on that point. Since there's three of them, it has to know which one are you going for, okay? And then you state the x equals answers. Okay, and so let's put a little note here. We're going to write the solutions. We're going to write the solutions as x equals. Okay, as x equals. So I noticed this first example right here. Okay, if they asked me to solve this algebraically, I would move everything over to one side. I would make a 0 and I would factor. Okay, but we're going to use our calculator this time. Right? And so the easiest thing to do, okay, where does this first part, so I'm going to say that this left side right here, this expression on the left is going to be my y1. y1 is going to be the left-hand side. Where does that equal? Where does that equal the right-hand side? So y2 is going to be the linear. Okay. Step 2 is to graph this in the graphing calculator. Okay, so the easiest thing to do would be to say, where does the left side equal the right side? Okay, so get out your graphing calculators. Y equals button right up here. Okay, that's what we're going to push, y equals. If you happen to have any equations in any of these, we're just going to hit the clear button and clear any of them out. Okay, and then you could go down to make sure all your y equals are empty. y1 is going to be 4x to the 4th. The x button is right here. There's your variable button, y 4x. Okay, I'm going to use the caret right here to the power of 4. Now I'm in the power, I got to get back down. Okay, so I'm going to arrow down 4x to the 4th minus 18. And then go down to y2. The second graph is going to be 2, use that x button again, minus 11. Okay, where does y1 equal y2? And then we're going to hit the graph button. So all your graphing commands are up here. And let's see. Oh, there's y1. Oh, it's way down there. Okay, I think I see some intersection points. All right, but I can't really find these answers till I can see them clearly. I want to go down a little bit farther in my view. Okay, so this is the x-axis, and this is the y-axis. So we're going to hit this window button and change our window. Change our window. The x max and min going from -10 to 10 was fine. It's the y minimum. Okay, let's change our y minimum to -20. Let's go down and then we're going to hit graph. Does that allow me to see things a little bit better? Oh, there's the quartic and there's the linear. Okay, so whenever you're using the graphing calculator, he is going to be doing lots of the work, but I need you to write some things on your paper. Okay, so the first thing is, what equations did you type in? Okay, the second thing is, what picture did you see? Okay, and you have to work with the calculator to get a really good view. Okay, if it's not a good view, get a better picture. So y1 was the quartic, and it kind of looks like this. Okay, so here's y1. And then y2 is this line with a y-intercept of -11. That's why he's so far down there. Okay, so we've got this y2. And do these graphs intersect? Yes, they do. They do intersect in two places. Okay, and so I know I'm going to have two answers. I'm going to use squiggly equal signs because they're probably going to be rounded. Okay, and let's go for this first one right here. Let's go for this intersection point. All right, so whenever you're doing calculator work, we're going to go to calculate right there. It's in blue, so we hit second, calculate. Okay, and we're going to do number 5, intersect. Intersect. Now, let's see, what's the first curve? It looks like I'm on y1. That's good. Okay, so hit enter. Okay, second curve. Is your second curve y2, the line? Yes, you just hit enter. Okay, this really only matters if we had 3 equations typed in. Which 2 do you want? Well, these 2. Okay, and now guess. So I'm going to use my left arrow, left and right arrow. Okay, I get close to this point that I want and I hit enter. Okay, and the x value there is -1.05. So the first solution is -1.05. All right. I noticed that this equation did not have any y's. When I solve this, you're going to get x equals. And that's what we're getting, x equals. The y values are because I introduced y's to make a graph. Okay, so we don't state y values, we state x values. Let's go try and find that other solution, okay? So you've got to start all over again. You've got to get to your commands. So go to calculate, second, trace. We're going to calculate intercept, number 5. Okay, first curve, enter. Second curve, enter. Okay, and now I have to arrow over to that point, and the solution right there, x is approximately, let's round it nicely to 2 decimals. We're always going to use 2 decimals in this class, 1.24. Okay, so there's the 2 solutions for this equation. Okay, and we're going to write the solutions using x values only. X values only. There are no y's in this original equation. All right, let's do it again. Okay, there's another equation. Okay, you could solve this by factoring. You could solve it algebraically. But I notice when our answers are decimals, you can't really get those from factoring. We need to have another technique. Okay, and that's where technology comes into play. So what equations should we type in the calculator? Okay, there's a couple of things you could do. The easiest thing would be to type right here, y1 being the left-hand side. So y1 is going to be that cubic. Okay, and then y2 is going to just equal the 0. Okay, is that possible? Sure. y2 is going to be the horizontal line right here. Here's y2. Okay, where does y2 intersect y1? All right, so let's go get our calculator stuff. We're going to go back to y equals. We're going to go down, clear all these equations so we can type in our 2 new equations. The first one is 2, get that variable button x, okay, then the caret to the power of 3. Make sure you go back down. minus 9x plus 5, and then y2 is going to be a 0. You have to type two equations to find an intersection, right? Okay, we're going to go to graph. And now this graph has the old window. Well, I don't know if that window's good. I know that I used to be down to -20. I don't need to go that far. Okay, but maybe up a little bit higher. So let's go to window and let's adjust. So I'm not going to go to -20. I'm going to go back to -10, but maybe the y max up to, like, I don't know, 14. There's no right or wrong answer. Some people say, what about 15? What about 12? Okay, as long as you go up a little bit, I think we're going to be good. Okay, as long as we can see that entire cubic. All right, y2 is right there along the axis. It's a little harder to see. Okay, so we have this cubic for y1. Okay, and in your calculator, can you tell that there are 1, 2, 3 x-intercepts? If it's a little tight and you can't see, maybe we could bring this x-axis closer. You don't have to, but what some people like to do is go to the window, and instead of -10 to 10, how about -7 to 7? Does that get in a little bit closer? Oh, I can see 3 x-intercepts now. Okay, the important thing is if you can't see them, you won't know to find them. All right, so I know from our picture, okay, y1 equaling y2 does have 3 solutions right here. 1, 2, 3. Okay, this is going to be the first solution, x2, okay, and x3. Okay, so solutions from the graph. x1 is about what? We're going to go to second calculate, and we'll do intersect. Is the first curve y1? Of course it is, so I'm just going to enter. Okay, now y2 is that horizontal line right there on the x-axis. That's good, yes, so hit enter. And then I'm going to go all the way over here, and I'm going to try to find that solution. And if I round to 2 places correctly, it's -2.36. Okay, you have to be good at rounding. Remember, in this class, we're always going to use 2 decimal places. That's about the right size. 1 is not enough, and we don't need to go more than 2. Okay. Let's try to find the second intersection point. So we've got to go second, calculate, intersect. 1, 2, and then guess. Okay. Now, you could go like this, okay, or you could actually type in a number if you want to guess. I'm going to guess 0.5, and it just takes me there. Oh, that's not right. Hang on, we got to do it again. Okay, if you don't get the right point, you have to make sure you get closer to it and then do it. Okay, so the second solution is 0.60. Okay. Please find that third solution, rounded to 2 decimal places correctly. All right, let's see what you got. Remember, you have to hit second, calculate, and say, once again, intersection command. The first 2 clicks can be fast. First curve, second curve, and then guess. Let's get closer by it. I hope you got 1.75. Okay. Now here's something else you could do. Okay, some people don't like having the 0. Okay, you don't have to have the 0 if you do some algebra. Okay, so let me show you this. What if I took the 5 and I moved it to the other side? Okay, you could do some rearranging, just don't make a mistake. You make a mistake, everything else is going to be wrong. Okay, and how does that change things for us? We're going to have y1. y1 is going to be the left-hand side. And then y2, okay, is still going to be the right-hand side, but now the number's -5. Where does y1 equal y2? Okay, and so in your calculator, you'd have a couple of changes, right? y1 does not get this. So delete, well, just delete one thing. Okay, clear does the whole line. But then y2, I need to change it to say -5. Okay. Another pointer for you. This is the negative button. This is the minus button. Okay, let me hit negative and then minus. You can see there is a slight difference. Negative is tiny and minus is big. The calculator does have a problem if you put a negative sign there versus a minus sign. Okay, so make sure you type the right one. Now when I go to the graph, okay, things are going to look a little different. There's the cubic, okay, but he's down a little farther. And then there's y2. Okay, so we still have a cubic. We still have a cubic, but this time, okay, y2 is down a little bit more. So what does that change for us? If I do second calculate an intersection, okay, 1, 2, 3, they're telling me that that second answer is 0.60. Okay, 0.60. Okay, so are the solutions coming out the same if you rearrange the equation? Yeah, the solutions are the same. Okay, the difference is now the y value is different. Okay, the y values here were 0, the y values here were -5, but again, we don't state y values. What kind of answers do we use when we state our solutions? We only look at the x values. Let's just show that the third one here is also going to work out. 1, 2, go over here. And the third solution is about 1.75. Okay, we get the same solutions. Okay, so it doesn't matter how you rearrange your equation, but you have to have left side equals right side. Okay, let's take a look at the last command in the calculator. Okay, and now we're going to talk about local maximum and minimums. Okay, so a local maximum is the highest point among all the neighboring points. Okay, so if I look at this point right here is the highest of everybody to the left and the right. So this is called a local maximum. Local, okay, for that area. The absolute maximum would be going up to infinity. Okay, but for this area, he's the highest. Oh, right here, I have another local maximum. Okay, everybody to the left and the right of him is lower. Okay, how about a local minimum? A local minimum is the lowest point, okay, among the neighboring points. So I know that negative infinity is definitely the lowest, okay, but this point right here, okay, he is a local minimum. He's the lowest point for everybody around him. Same thing right here, local minimum. Okay. Now the question is, okay, what's this point right here? Is that a local max or is that a local min? That's nothing. That's nothing. That's just there to trick you. Okay, a graph has infinitely many points. There's many, many points on a graph. Okay, and they're not local maximum or minimums sometimes. It's just the highest one or the lowest one. Okay, so that point there is just to confuse you. Trick you. All right, true or false? There are a limited number of local max and mins. Are we only allowed to have, say, 2 or 3 local mins? False. False. You can have as many as the graph has. Okay. If this graph went up and down, up and down, up and down, up and down, a lot of times there'd be local max, local min, local max, local min, local max, local min. So there's not a limited number. Okay. It depends on how many the graph has. All right. Now, how do you do this with technology? All right. You're going to graph the one equation. Okay, that's what's different about this. You just graph one equation in your calculator. Get a good window. Okay, we're going to use the maximum command or the minimum command. All right, and then once again, there are 3 clicks. So click 1, you click to the left. Click 2, you click to the right. Click 3, in between. Okay. All right, so let's take a look at an example here. Okay, here is a graph that I have to get a good view of before I can find all the local max and min. Okay, so when you go to graph this in your calculator, clear out anything that you had before. Okay, and what we'll do is we'll start with x to the power of 4 minus 7x squared plus 6x. If you need more time to type that in, go ahead and pause the video and finish your typing. Okay, and then after you get it typed in, we're going to go to the graph. Okay, now I have the same window from before, so we'll see how that works. Okay, so in terms of the x-axis, it seems like we're seeing everything. Okay, and then in terms of the y-axis, it seems like maybe we need to go down a little bit more. Okay, so I'm going to check out my window. X-axis is fine. The y minimum is negative 20. Maybe I'll try going negative 30. Negative 30. Does that show us enough? Absolutely. Okay, you don't want to cut it too close. Remember, we're trying to find the maximum and the minimums. Okay, now the scale does look a little weird. Okay, if I look at my y-axis, okay, so let's just go back to window for a second. If you were to draw a graph by hand and go all the way to negative 30, I don't think you would do tick marks every one. 1, 2, 3, 4. That seems a little too much. So the scale, the y scale, maybe what we should do is go by fives. 5, 10, 15, 20. Okay, and then if you go to your graph, the scale looks a lot better. Okay, don't spend too much time playing with the window. Just make sure you can see everything you need to. Okay, and then move on. So what does our equation look like here? It's a quartic. It goes down, then it goes up, down, up. Okay, so just draw a good graph of what you see. Okay, and then I notice here in terms of the local max and the local mins, okay, there's 1, 2, 3 points we have to find. Okay, and here's how the calculator works. All right, we're going to click to the left and we're going to give it a boundary. Then we click to the right of the minimum. Okay, then you're going to click right there in between. Okay, so there are 3 clicks. So let's go for this first one. Let's go for this minimum. So we go back into our calculate command. Okay, and the command we're going to be doing is minimum. We're going to pick number 3 because I know that it's the minimum. All right, now you have to go left, left, left. You have to go to the left until you pass up the minimum. Okay, don't go crazy. Where's my cursor? It's totally gone. Okay, you want to get to the left, okay, but you don't want to cut it too close. Okay, am I to the minimum or am I touching the minimum? Sometimes if you can't tell, get away a little bit. Okay, there's your left boundary. And you hit enter. Now it wants right boundary. Okay, so it wants to know like what, give me a window to look in. So I'm going to go to the right. Is that enough to the right? No, you have to go more to the right. Okay, is that good? No, okay, I can't even tell what's going on there. Make sure you go to the right until you've clearly passed up the minimum. That is definitely passed, so I'm going to hit enter. And now it wants a guess. Okay, so now I'm going to go right there at that minimum point. Okay, and the lowest point between those 2 boundaries is the point negative 2.06, comma, negative 24.06. 24.06. Okay, what's different about this, okay, is we're finding maximum and minimum points. We're finding points. These are not solutions, these are points. And remember, to write a point, okay, you're going to write it in x comma y form. Okay, so these are points. Points need parentheses with an x and a y value. All right, let's find this next one up here. Okay, this one is a maximum. So in the calculator, you're going to go to second calculate, and now we're going to pick number 4, the maximum. Okay, so for this point, the calculator is going to want to know a left boundary and a right boundary. Okay, and then we'll click right there in the middle. All right, so let's go to the left. Okay, am I to the left of that maximum point? Yes, hit enter. Now you have to go to the right. You have to pass up the maximum. Okay, that is clearly past the maximum. So I'm going to hit enter. And then see these little arrows? Okay, the calculator is going to be looking in between there to find the maximum. I'm just going to get as close to the maximum point as I can and hit enter. The coordinates of this maximum, since it's a point, okay, I'm going to write it as 0.46, comma 1.32. All right, we have one more point to go, right? We've got one more point right here. Is this a maximum or a minimum? Yep, that's going to be a minimum. Okay, so second calculate minimum. Okay, I'm to the left of that point, click. Then I'm going to go to the right of that point, click. Okay, please go down right there near that minimum point and tell me what you got for the coordinates of this minimum point. Okay, so when you hit enter, I hope you said 1.60, comma, negative 1.77, rounded nicely to 2 decimal places. Okay, so we did lots of calculator work today. Window, okay, window is where you can change the size of the viewing screen. Okay, zoom, zoom is where you can zoom in or zoom out. A lot of times we zoom standard. Okay, standard is the 10 by 10 window. Graph is where you can go to see a graph real nice. Okay, and then y equals is where you type them in. Okay, remember, whenever you're solving with a calculator, you must show a good graph. Show me what you saw in your calculator. All right, show me the algebra that puts the equations in a y equals form. Okay, for this one right here, I just typed in one equation, so I don't really need to do any algebra. I typed in one equation for one graph. Okay, can you examine the graph and determine what kind of symmetry it has? Can you solve an equation by finding some x-intercepts or some zeros? Here, intersection point, okay? That is when you have two equations, and then you find where they touch. Okay? Can you find the local max and mins using the graphing calculator? Okay, good job, guys.